Hello guys and welcome back. In this video I wanted to talk about hardware and what can you expect as an effects artist and the kind of hardware you need to be able to create effects or work smoothly on various types of effects. Now I don't have any magic recipe for CPUs or what is the best value you can get for the money that you have and stuff like that. I'm going to show you what it takes to save the data that we're going to be creating. I'm going to show you how much memory it takes to create 30 million or 40 million points and save them, process volumes and things like that, and why sims are heavy and why the render times are generally high. So I have these two here. I'm going to leave this folder always on the top. I'm going to leave this here. This is showing me the memory. I have 240 gigabytes of memory at the moment, 241. Used is 10 gigabytes and free is 228. So we're going to focus on the used section on this part. And I'm going to create a GeoNode. I'm going to create a grid. And let's say we have a particle sim that generated 10 million points, and we can simulate that. I'm going to open this here, and I'm going to create 10 million points. So that's 100,000. Sorry, I'm going to create 1 million, and I'm going to move this to the side. I'm going to save this to disk. And use a ROP output. Actually, let's move this here, and I'll bring this when we need it as well. So let's save this to particle 1mil.geo.sc. The geo.sc is the format that we need to use. The sc is the type of compression to help reduce the size, the file size. So let's hit save. Memory not so much, it didn't use up a lot more, and the file is here. Actually, let's just use a shell for this. Okay, so it's 10 megabytes. You know what, here it's easier to read. Let's do this. So 10.8 megabytes per frame for 10 million points. 1 million. Let's increase to 10. It's taken some time to calculate that. And let's hit save. And I think, yeah, we overwrote the file. So this is 10 mil. And it's 100 megabytes. So let's store the. So this is the 1 mil, this is the 10 mil, and in some cases you would need 50 mil. So let's hide this. I don't want to see it so that it computes faster. It doesn't have to display the points. And change the point to 50. I'm going to hit save. And the memory for some reason is not changing. Okay, well that's good. And this looks like a 5 million. Let's change this to 50. And you can see we have 100 megabytes for the 10 million points. And what we're storing right now is just one attribute, the point attribute, the point position. And when we import the data from the sim, or when we process it, we add new attributes to that we probably need them in the shader. For example, we need velocity. Sometimes we need an ID attribute, which is a unique number per points. Sometimes we have a color attribute. So let's add that. Let's take this 10 mil and add some attributes to it. And you see 50 mil is 500 megabytes per frame. So let's do some math. So 500 500 per frame, let's say 0.5 gigabytes multiplied by 100 frames. That's 50 gigabytes just to store 100 frames, one version. If you have, let's say, 10 versions that you want to keep, that's 500 gigabytes for one FX sim. Just one pass. Okay, let's continue. The memory is still pretty low, which is good. So let's add a new attribute. Let's add a random node, and we're going to call this color. I want the color to go between 0 and 50 and 500, 2.1.5, just to have something. And I'm going to call this CD for color. I'm going to copy that. I'm going to call it V, and let's generate a direction or orientation. And this is an attribute, velocity attribute, and let's add an ID attribute, and this is going to be an integer. So the type here is going to be, where do we specify if it's an integer? Well, we can create a float, that's fine. It's not exactly the same. So let me use a wrangle to create an ID attribute. It's equal to point num. Again, don't worry about this. So now if we middle click on these guys, we have color, ID, point, and velocity. And this is most of the time reasonable. And let me increase the point count to 10 mil. And let's change this to 10 mil. So previously it was 100 megabytes with just one attribute. Let's see how much it is. And with the disk speed that you have, depends on how much you have. It's generally 170 megabytes read, and let's say 180 megabytes read and write. So if the file is 530 or 540 divided by 180, that's 3 seconds to save the file, and probably another 3 seconds to read it back in. So there is an overhead to that. The heavier the data, the more save time is gonna increase. Now see, the data went from, let's save it back without any attributes. So 10 mil, no attribute. And it went from 100 megabytes to 320 for just 10 mil. Let's do it. Let's do the same thing with this and see the increase. So I'm going to hit save. For the 50 mil, I'm going to call them with attribute. Cool, so it's saving, and you can see now with 3 attributes added, the size almost tripled, or more than tripled here. So it's very, very important when you save the caches to know, to be aware of the attributes that you're storing and reducing that to as low as possible so you don't increase the file size. But this is the average size for 10 mil. We're expecting to 100 megabytes, and 10 mil is not that high. It's something that we work with a lot. It's a reasonable number. 50 mil is high. 1 mil is like the beginning level, but for quality you would probably be going between 5 to 20 mil for some of the effects. And there is no restriction. The higher the point count is, the more details you can get in when you render the particles, but the slower it's going to be. Now overall the memory hasn't changed a lot, so it's still 12. I'm not seeing it jump or anything, so it's reasonable. And if we look at the 50 mil, it's 1.6 gigabytes per frame. So It's very easy. 200 frames will be 300 gigabytes, and you will soon be in the terabyte. So this is with just particles. Okay. So yeah, that's the stuff we have to deal with. So let's create a geo, and in this case I want to create a volume, and this volume we're gonna save to disk, and this is what a smoke sim will be creating. So I'm gonna use a VDB from Polygon, and I'm gonna increase the resolution quite a bit. And let me copy the V. I'll explain why later. Okay, so you can see it's a volume. It's a cool volume. And let's add some noise. I'm going to use a node called Cloud Noise. To noise up the volume a bit. Okay, so right now we don't have a lot of voxels. It's 1.6 million. Still very low to mid quality. I'm going to increase that a lot more. So 0.04. And I'm just trying to get the number of voxels that is equal to the resolution you need to create a high-res sim. When you do a smoke sim or anything like that, that's the number I'm looking for at the moment. So it's adding the noise. The reason I'm adding the noise is because this algorithm can optimize the data efficiently if it's very smooth and very similar to each other. So I'm adding the noise to make it harder for the algorithm to save disk space. And that's with the cloud noise. Now you don't have to worry if you don't know voxels or any of these attributes. Think of this as a geometry now that we're saving to disk. That's it. Okay, let's take a look. So this is reasonable. Okay, 25 mil. This is good. And same like we have with attributes. If I middle click, I did click on the 50 mil. Okay, let's wait for it. So similar to the attributes that we create on points, with volumes we can also create attributes and store more than just one float. So we don't need just one guy. So here it's a P only. If I middle click on this guy, there's density, and it's still density. And you know what? This node is heavy, so I'm gonna remove that for now, and I'm gonna save this to disk, and it's 14 million. So keep that in mind. Let's expand this. So vol 14 mil. Let's save it to disk, and it's 7.5 gigabytes. Let me do something. Volume wrangle. I'm going to increase the density. Again, this is just to quickly create some data. Okay, and let's hit save again. Interesting. I was expecting it to be a lot higher. So let me create the noise myself so it's faster. And hopefully we'll add some more to the data. Okay, that should noise up the volume. Yes, it did. Let's increase the frequency. Okay, let's see how that looks. I'm very surprised at the data. Yeah, I see you know what, I'm gonna do this. I'm gonna create a box of 10 units. Again, the algorithm is gonna try and save the data, and I'm not gonna create a VDB, I'm gonna create something else. So let me delete all of this, and this should give us a better indication. Okay, let's call this density, and let's save this. You have 1 mil, let's set this to 500. Almost there. It's creating the volume here, and the memory is not changing a lot, which is good. I mean, this the SOP stuff is not memory heavy, but once we start doing sims on that, the memory usage is going to go up a lot more. Okay, I'm gonna pause and come back when this is done. So I'm back, and the box idea didn't work as I had hoped for. It's not generating the data I need, so I imported an explosion that I already made, and this one has a density field. The resolution is quite high here, but I wanted to use it as an example to show you guys. So this contains only one field, and you can see it's 430 megabytes for this frame for one field. Generally you would need other fields like the temperature, the velocity, for example. So let's create that. Let's fake the velocity field. So I'm gonna copy the density, and I'm gonna name this from density to vel.x. This is just a hack to create the vector field. Okay, I'm gonna merge them all. Sorry, I'm gonna merge them all, and then use a node called vector merge. And now we should get a velocity field, a vector field, because the other one is a float field. Think of it, which is much lighter to create, and this is a vector 3 field. Now I'm going to add some data to it. Let me create a volume VOP. I'm just going to create a noise and plug it into that field. Let's create a curl noise, connect the position, and then bind export this. Again, none of this is required. I'm just doing this for the data generation. I'm gonna get into all this later and explain it thoroughly for you guys. So now I have a vector field with some data on it, and this is the resolution. So let's merge it back and say this is the sim had a two fields, density and val. This is very typical, and let's save this explosion with val. And it's saving, and the memory usage went up quite a bit because it's very heavy to process this. You can see it went up to 24 gigabytes from 12, so it used almost 10 gigabytes. Houdini is using 10 gigabytes now, and we're just processing one field. When we get to sims, the solver is gonna be processing a lot more fields, and that will take up a lot more memory than just this. But again, this is a very extreme case. So the file with velocity is almost 3 gigabytes per frame. So 100 frames is 3 terabytes. Yeah? 100 frames is 300 gigabytes. So that's something to keep in mind. And again, the memory usage, you see just 12 gigabytes to save this. I'm going to do a resample node to reduce the resolution of this. Let's see. Larger. So let's scale this to 4. I want to lower the resolution to something that is in the mid level, and this is low. Let's see, 3. 2.5. I want to get 600 on one of the axes. Yeah, that is very close. Okay, so yeah, this is a reasonable, a decent high-res sim, but the entry level. So it's 18 million. So let's call this 18 mil. And let's save it. And this is what you guys will probably be working with in terms of data. It's much lighter, so that's very good. Let's try up it a bit more, 2. So let's see, 28. Yeah. Cool. So it's very reasonable, and if we don't save the velocity, then it's going to be much lighter for just the density field. And maybe in a lot of cases you don't need to save, you only need the density field and maybe the temperature field. So yeah, this is the 18 mil no val. Oh, here. Yeah, it's 57. So this is very reasonable. And these are just some numbers so you guys get an idea. You can see memory went up a lot by us just playing with these values. So it's very important to have enough memory. And I'm pretty sure you guys got the idea. The more you have, the more resources you have, the faster the sim is going to be, and the more data you can push through. The slower, the less disk space you have, the more limiting it's going to be for you to create effects and push quality. And that's the reality. There is nothing that we can do really to alleviate that. FX is very demanding, as well as rendering. We're going to learn a lot of tips and tricks to optimize things and make use of a reasonable hardware that is not very expensive to get quality effects, high-end quality effects, but again, it doesn't mean that we can shortcut everything. So hope you guys find this useful, and talk to you soon. Bye bye.